Alright, good day everyone. So welcome back to my YouTube channel, and it's Kasaligan Vlogs. And today we'll be talking about transformation of trigonometric integrals, and it's part of integral calculus. So there are ways on how to use transformation of trigonometric functions. The first one is the product of form sine AU, BU, sine BU, sine AU, cos BU, and cos AU, cos BU. So when we have seen like this, so this is the integrated, can be integrated by the use of transformation. So that like this. So these are the transformations that we're going to use when we are going to use transformation of trigonometric functions. The next is the product of the form of sine mu cos nu, whether either m or n is positive integer, can be integrated by the use of these identities. Okay, and we have also number 3, a product of sum sine mu cos nu, where either m or n or both positive integer, can be integrated by the use of this integration. Okay, and we have here the power of form tangent nu and cot nu. So this is the transformation, and the power of sec nu and cosecant nu, and these are the transformations. And we have here the product of the form of tan mu sec nu. These are the transformations, and where n is even, where m is odd, and where m is even and n is odd. So these are the transformations that we are going to use in this topic. Okay, so let us have first transformation number 1 example. The integral of sine 5x sine x dx. So in this case, this is the case of the integral sine 5x sine x dx. So the transformation that we're going to use here is we are going to transform sine 5x is equal to, so sine 5x could be transformed in a form of 1/2. This is the product of sine. So we'll be making use of case number 1, which is sine A, sine B. Okay, sine A, sine B. So this is the product. So sine 5x is equal to 1/2 cosine, we have here A minus B minus 1/2 cosine A plus B. Alright, so this is in a form, no, rather, this is 5x sine x. Okay, so sine 5x and sine x is equal to 1/2 cos A minus B, 1/2 cos A plus B. So this is in the form of this, so we will transform 1/2 cosine of, what is our A? So we have here 5x minus B is, if this is our A and this is our B, so therefore we have here x minus 1/2 cosine, which is 5x plus x. So we have here 1/2 cosine of 4x minus 1/2, we have here cosine of 6x. So this is now being transformed here. So instead of writing this part, so we will write here the integral of, after the transformation, we have now the integral of 1/2 cosine 4x minus 1/2 cosine 6x, and this is dx. Okay, so first, the next part is we are going to integrate by parts. So we have here 1/2 cosine 4x minus 1/2 cosine 6x, rather dx, and this is dx. So our u here is 4x. Our du is equal to 4 dx. So therefore our nf is 1 over 4. Our u here is 6x and our du is equal to 6 dx. Our nf is 1/6. Next step is we're going to use the integration. So we have here, okay, this is integral by the way. So this is 1/2 the integral of, okay, cos u du minus 1/2 the integral of cos u du. Here 1/2 the integral of cos u times what is our du with a given nf, which is 1/4. So we have here multiplied by 1/4 du minus 1/2 the integral of cos u times the nf, which is 1/6 du. Alright, so this is 1/8 the integral of cos u du minus 1 over 12 integral of cos u du. Next, we have to substitute now. So this is the integral of this part is cos u is equal to sin u. So what is our u? Immediately we will substitute here, which is 4x. So therefore 1/8 sin 4x minus 1 over 12 sin, we have 6x plus c. Alright. So next we have here 1/8, or the final answer is 1 sine 4x over 8 minus 1 sine 6x over 12 plus c. Okay, so this is the final answer. Okay, so sine 4x over 8 minus sine 6x over 12 plus c. So this is the answer for number 1. This is transformation number 1. So let's proceed with transformation number 2, which is sine squared x cos cube x dx. So this is case number 2. Okay, so we are now in case number 2. So we have here sine squared x plus cos cube x dx. So the first thing is we have to transform this part. So we could transform, because when you let u, since the derivative, we have to anticipate that the derivative of sine is equal to cos. So therefore, we have to factor this part. And this is in the form of the equation of this part is we could integrate. We have here sine squared u is equal to 1 minus cosine squared u, and we could also have cosine squared u is equal to 1 minus sine squared u. So these are the transformations that we are going to use. So first we have to factor, okay, cos squared x, we have to factor cos x, and this is the x. Alright, so after we have factored this one, okay, so we have the integral of sine squared x cos x dx. So we have to transform this part into sine. Okay, sine. So we have here, we are going to make use of this one because we have anticipated that the derivative of sine is equal to, we have here the derivative of sine is equal to sine x is equal to cos x dx. Okay. So first, next is we have here sine squared x, and we have here 1 minus sine squared x, and this is cos x dx. Okay. Next, we have to distribute, so sine squared x minus sine 4x, and this is, oh no, this is cos x dx. So now, we have now to integrate this part. So let us use our u is equal to sine x. Our du is equal to cos x dx. So therefore, we could now make use of our du cos x dx as our du. So therefore, the integral of this one is u squared minus u raised to 4, the integral of du. So after that one, we have to integrate. So this is u raised to cube over 3 minus u raised to 5 over 5, then plus c. So what is our u? Our u is equal to sine, so therefore sine cube x over 3 minus sine 5x over 5 plus c. Okay. So this is the final answer for number 2. So the use of these transformations. And this is case number 2 also. Next we have number 3. So in number 3, we have here the integral of sine squared 3x and cos squared 3x dx. So if you're going to note, if you have noticed that this case belongs to case number 3 also. This problem is belong to case number 3 where both positive even integers. Alright. So both positive even integers can be integrated. So therefore, this is 2 and 2 are even. So we could integrate using case number 3. Okay. In case number 3, we have here cos, and we're going to make use of cos sine squared and cos squared. So what is the transformation of sine squared u is equal to 1/2 minus 1/2 cos 2u. And the transformation of this cos squared u is equal to 1/2 plus 1/2 cos 2u. Right? So 1/2 plus 1/2 cos 2u. So we have now to integrate this part. So integral of sine squared. So we have to substitute here 1/2 minus 1/2 cosine of 2 times what is our u here, which is 3x. Then after that one, multiply it by cos squared, just 1/2 plus 1/2 cosine of 2 times 3x, then dx. Okay, so now after that one, we have to distribute the sign. So this is in the form of a minus b and a plus b. So the result of this one is a squared minus b squared, because minus and plus. So just multiply the first term and the last term. So the integral of this part will become, okay, so this is 1 over 4 minus 1 over 4 cosine squared of, this is 6x dx. Okay, understood? So how to come up with this part? By the use of this identity in algebra, which is just square and square, multiply first and first, second and second. So because this is the property of algebra. And after that one, we have to extract 1/4, the integral of 1 minus cosine squared 6x dx. So after this part, since cosine squared, 1 minus cosine squared is equal to sine squared, so we have to integrate again. We have to transform 1 minus cosine squared is equal to sine squared 6x dx. Diba? Okay. After that one, we have to use again this part. So 1/4, the integral of 1/2 minus 1/2 cosine of 2 times 6x dx. Okay. So after this part, so we have here, we have to extract this 1/2 1/2. This is 1/4 times 1/2, the integral of 1 minus cosine of 12x dx. So no identity now. So we can have our u is equal to 12x. Our du is equal to 12 dx. Our NF here is 1/12. Next, we have to simplify. Okay, we're going to make this bar. Okay, here, we'll proceed here. So this is 1/8. The integral of dx minus 1/8 the integral of cos 2x dx. So separated siya. So 1/8 dx, the integral of 1/8 dx is equal to, alright, so 1/8 dx, 12x rather, this is 12x. So 1/8 x minus 1/8 times 1/12, which is the NF, the integral of cos u du. So 1/8x minus 1/8 and 1/12 is 1/96. And the integral of cos u du is equal to sine u. So sine 12x plus c. So this is the answer for number 3, which is case number 3 also. So next we have number 4. So in number 4, we have the integral of sec x plus tan x is quantity squared. So first is, this is case number, okay, this is case number 4. So we have 2 is a positive or can be integrated by the use of trigonometric identities. So n is a positive integer. So second, okay. First thing that we're going to do here is we're going to distribute. So integral of this one is, we have secant squared x plus 2 sec x tan x plus tan squared x dx. After that one, we have to simplify it by terms. So we have here the integral of secant squared x dx plus 2 the integral of sec x tan x dx plus the integral of tan squared x dx. So next we have here the integral of sec squared x dx is equal to tan. So therefore this is tan x plus the integral of sec x dx is sec u tan u is equal to secant x. Then plus, since no integration of tan squared here on the formula, so we have to transform this one. So by the use of transformation, that is case number tan squared, that is case number 4, which is we could integrate as 1 as secant squared u minus 1. So therefore, we have the integral of secant squared x minus the integral dx minus the integral of dx, which is our 1. So therefore, we have here tan x plus secant x plus the what is the integral of secant squared x dx, which is tan x. Okay, so tan x and minus x plus c. So therefore, we have here 2 tan. So 2 tangent x plus secant x minus x plus c. So this is the final answer for number 4. Okay, so moving on to number 5, which is tangent squared 2x secant for 2x dx. So we have here the problem in this case is tangent squared. So we are now in case number, okay, let's have tangent. So tangent is we have here is a positive even integer. So where n is greater than 2. So we have here case number 5. Now in case number 5, we could make use of case number 5, which is a positive even integer can be used integrated trigonometric functions. So we have pwede. Okay. Or we have number 6 in the form our positive integers can be integrated also. But we have to make use of number 5 here. Okay. So integral of tan squared 2x secant for 2x. So the first thing that we're going to do is we have to factor this part. Because what is the derivative of tan? We have to anticipate that the derivative of tan is equal to secant. So integral of tan squared 2x is equal to secant squared 2x. And we have here secant squared 2x dx. Next, we have here the integral of tangent squared 2x secant squared 2x. Okay, 2x. This would become secant squared 2x is equal to 1 plus tangent squared 2x dx. Okay. So next, we have here 1 plus tangent 2x. We have to distribute this part. So after we have to distribute here, okay, this is, we have to close this part and we have to distribute. So the integral of tan squared 2x secant squared 2x then dx plus the integral of here and here we have tan for 2x secant squared 2x dx. So after this part, we have tan squared 2x secant squared 2x plus this part. We have to take our u as equal as tangent 2x. So our du is equal to the integral of this part is equal to 2 secant squared 2x dx. So therefore, we have here 1/2 du is equal to secant squared 2x dx, which is our nf is 1/2. Okay, so our nf in this part is 1/2. Okay, so next part we have the integral of, okay, since 1/2 we are 1/2 tangent u squared du plus we have here 1/2 also 1/2 integral of u raised to 4 times du. Okay, so 1/2 u raised to u squared du plus 1/2 u raised to 4 du. So where did you get the 1/2? Because we have here 1/2. Okay, just move immediately here before the integral sign. So we have here, when to integrate this part, we have 1/2, okay, u cubed over 3 plus u 1/2 u raised to 5 over 5 plus c. So this is u cubed over 6 plus u raised to 5 over 10 plus c. So what is our u here? Tangent. So tangent cube 2x over 6 plus tangent 5 2x over 10 plus c. So this is the final answer. So now we are moving on to number 6 rather. Number 6 is tan cube x sec cube x dx. So in number 6, we have here, we could transform, so the same pattern, almost the same pattern with the next part. But since this is cube and cube, we could immediately, the technique here is we have here tan cube x sec cube x dx. This is cube. The technique here is tan squared x secant squared x. Then we have here tangent x secant x dx. Alright, so why is it that we are doing here? Because we anticipate that, we have to anticipate that when we let u as our sec, when we differentiate that one, the result is sec u tan u, right? So that is the derivative of this part of sec. So therefore we have to transform, which is one we are going to transform here. So that the trigonometric function that we're going to transform here is the tangent, not the secant, because when we let u as our secant, when we let u as our secant, when we take the derivative of this one, the result is sec u tan u. So that's why we have to transform this part to have an easy way. So tan squared is 1 secant squared x minus 1 times secant squared x. Then this is tan sec x tan x. So just follow the format, sec u tan u later. Okay, so we have to distribute this part, distribute here. Okay, so after we need to distribute, so after we have to distribute, so we have to, okay, integral of secant okay, so secant raised to 4 minus secant 4x minus secant squared x, and this is sec x tan x dx. After that one, we have to distribute. So integral of this one is sec squared x 4, then secant x tan x dx minus the integral of secant squared x times secant x tangent x dx. So we have to let u as our secant as our u. So the derivative of this one is equal to sec x tan x dx. So therefore our du is equal to this part. So integral of what is our sec, this is our u, so therefore u raised to 4. Our du is equal to sec x, so therefore this is our du. squared minus the integral of u raised to squared, u squared rather, times du. So if we're going to integrate this one, u raised to 5 over 5 minus u raised to cube over 3, then plus c. So next we have here, what is our u, which is second. So second raised to 5x over 5 minus second cube x over 3 plus c. Okay, so this is the answer. So second 5x over 5 minus second cube x over 3 plus c. So this is the answer for number 6. Okay, so moving on to try this, evaluate the following using the concept of transformation. So you have to pick the best transformations that we're going to use. So thank you so much for listening. I hope you will answer this part. And God bless for this transformation of trigonometric function. Thank you, and do not forget to subscribe to the channel.